Okay guys, so let's continue on seeing more examples of calculation of n factor of compounds. Okay, so next example is of MnO4 whole twice. This actually gets converted into Pa plus 2 and Mn plus 2. So if you just calculate the oxidation state of Mn here, so it goes from plus 7 to plus 2. So 1 mole of Mn goes from plus 7 to plus 2. So there are 2 moles of Mn in this compound, so n factor for this compound Mn n factor of Ba Mn O4 whole twice would be 5 into 2 or 10. This would be the n factor. Okay, as 1 mole of MnO4 2 minus contains, rather the compound contains 2 moles of Mn. Okay, next example is n factor of O3 getting converted into H2O. So 1 mole of oxygen is gaining 2 moles of electrons, and there are 3 moles of O3 in 3 moles of O in O3. Okay, so this implies, and also 1 mole of O acquires 2 electrons, hence combining the two information we get n factor of O3 as 6. Okay, let's see another example wherein we have CuS getting converted into Cu plus 2 and SO2. So here and oxidation state of Cu is plus 2, S is minus 2, copper is retaining its oxidation state or oxidation number, but sulfur is going from minus 2 to plus 4. Okay, so n factor would be 6 for CuS. Next, let's see a compound VO, vanadium oxide, undergoing oxidation, converting itself into V2O5, where oxidation state of V goes from plus 2 to plus 5. Hence, the n factor of VO would be 3, as the electron loosed by 1 mole of VO or 1 mole of V is 3, and 1 mole of VO contains only 1 mole of V. Let's see another example. We have Fe2O3 converting into Fa plus 2. Okay, so again n factor here would be plus 3 is the oxidation state of Fe here, getting converted into plus 2, and n factor would be number of electrons gained by 1 mole of Fe would be 1, and how many moles of Fe are present in Fe2O3? 2, hence the n factor of Fe2O3 would be 2. Next is we have Fe in 0.94 atoms of Fe combined with 1 atom of oxygen, or either we could term or you replace a term atom with mole, getting converted into Fe plus 3. Okay, so what is the oxidation state of Fe here? So we have 0.94 times of X minus 2. This is the oxidation state of oxygen, and overall compound should be neutral. So this implies that X is 2 upon 0.94. So this is the oxidation state of Fe plus 2 upon 0.94. So this is going to Fe plus 3 state. So number of electrons gained or loosed would be 3 minus 2 upon 0.94. Okay, and so oxidation state of rather than n factor of Fe 0.94O would be number of electrons, this multiplied by the number of moles of Fe in Fe 0.94O. So number of moles of Fe is 0.94 in the overall compound multiplied with number of electrons gained or lost, which would be nothing but this. You can calculate from this. Okay. So let's see another example. We have Na2S2O3 getting converted into Na2S4O6. Okay, so in this S is in +2 state, okay, which is getting into +5/2 state. Okay, so number of moles or number of electrons released by S2 would be 0.5, and how many number of moles of S2 are there? 2. So n factor of Na2S2O3 would be number of electrons released into number of moles released by S2 and into number of moles of S2. So n factor would be 1. Okay, let's see another example. C242 minus getting converted into CO2. So in this case, oxidation state of carbon is +3, going to for +4. Now n factor would be 2, as 1 mole of oxalate ion released 2 moles of carbon. Now when more than one element change their oxidation state in given compound, we are going to see that case when more than one element changes its oxidation state. So far we were dealing only with one element in the compound changing its oxidation state. What happens in this case? So suppose we have FeC2O4 converting into Fe +3 and CO2. Okay, so Fe here is in +2 state, C here is in +3 state, Fe going to +3 state and C going to +4 state. Okay, so n factor would be simply the addition of the substances which are undergoing oxidation. Fe, for Fe it is going from +2 to +3, so number of moles of electrons going away from Fe in this case is 1, and number of moles of Fe in the compound is also 1, so multiplied with 1, plus number of electrons lost by carbon atom in the reaction is 1, and number of moles of carbon atom present in the compound is 2, hence the oxidation state is 3. Okay, so in the next lecture we'll be continuing on seeing more examples of calculation of n factor when more than one element changes their oxidation state in the course of reaction. So till then, good luck and goodbye.